Hey, what's going on, guys? Coming again here. What I've done so far without covering in a live coding session is the absolute addressing mode for STA instruction, and the reason for that is because I've slightly optimized the code to write the value to the memory. So here's how the output works. So we have the value 45 in the A register. We're going to be writing this to 0104, so bear in mind the little endian order here. 0104 absolute memory address in the 6502 simulated memory, which starts from the offset E000. So here it's like 100s 0, 2, 3, 0, 1, 2, 3, 4, and this is the state of the emulated memory before we have written a value there, and here is the memory state after we have written the value there. So we got 45 here. Okay, so yeah, for those interested, what I've changed is, so it's better to look like this. So STA, no, set memory value, right, here it is. Okay, and now both 0 page sets STA to 0 page, STA to 0 page with the X offset, and the absolute STA with the absolute addressing mode, they all reference this set memory value procedure, which just does that. And the code is handled not I refused to make this how I've been doing for get, like get 0 page, get absolute, get index indirect indexed, because this code is going to be reused many times by add with carry, subtract with carry, and what else, like and or, XOR, so all these logical operators as well. So really lots of reuse for getting the memory. However, the only instruction that sets the value to the memory is STA. So well, as far as I'm aware, there are no other instructions in 6502 assembly that would be doing this. So just to keep code simple, I decided to put this the logic that differs into the STA implementation on its own. So for instance, here we have the STA absolute value. We just load in the word. All right, and we're going to be reusing this in this video already. And also, for instance, STA 0 page X just loads the byte, then finds the address in the memory, and then adds the offset from the X register. STA 0 page X, and just the STA 0 page does the same, but without adding an offset from the X register, right? So and all they use this called set memory value here. STA here also uses now set memory value. So the only instruction and all the code that differs is put in front of this function call, this procedure call. All right, so again, like, just have a look. So we got this absolute addressing, right, for STA. So the next thing to consider would be the STA. So we got these three currently. So absolute and the X offset, and absolute and the Y offset. So these are the next addressing modes to be covered. And then if it doesn't take ages to complete, we'll try at least to start looking at indirect addressing, because this would involve writing some new code, which I didn't yet write and test, so that would be a bit more challenging as opposed to what we're currently going to be doing here. Okay, so here we have this absolute, all right, absolute thin. Okay, so I just grab co partially up to well, I guess up to execute, copy. This is gonna be, well, yeah, I've been using, yeah, why the heck was I using these jumps? I didn't really need to do that, to be honest. So just wondering if I just get rid of those, they should be working the same. I already don't remember why did I consider those jumps. Probably I was going to jump to somewhere else rather than the next test. I don't remember really. So yeah, actually I have no idea why have I been maintaining this unnecessary jumps for such a long time. All right, so here, copy, paste, and test number 4. So let's try somewhat a different value. Let's say, I don't know, whatever, 57 for instance. Okay. And what we got here, so, well, first of all, the label is wrong, so let's fix the label. Set a register to value of 57. Here would be x, absolute addressing plus x. All right. There would be the same address. I just need to alter the opcode. This is going to be test absolute x. I'm not sure if I need to put a space there. Oh no. Yeah, absolute x address. And so I've just altered the label, right? And now let's have a look at the opcode, at the corresponding opcode here. So this is it, 9D. So 9D, all right. Okay, so we got a new altered label, 9D, and the address is the same, but we're going to be using the offset in the X register, which we already have there, and we're going to be writing the value right in the cell right next after 0104, right? So here is the place where we're going to be writing the value of what we have there, 57. Okay, so far so good. And yeah, so the next thing is to call the execute and see how it works. So grab this one. All right. Did I miss anything here in the comment trace? Well, hopefully not. Maybe I did. Doesn't matter. Okay, so let's implement. Oh, I've just lost this one. So execute, and here. So I want to compare AL with this constant, which is the opcode for STA with the absolute addressing mode plus X offset. So is this STA absolute plus X offset opcode? If so, then we need to execute it. So STA ABS X. Okay, If so, then execute it. And now I just need to find the proper place for of where to put this STA ABSX. I'm gonna be reusing the code from STA ABS. So this is the code I'm gonna be reusing, right? Okay. Copy. And where is the place to, yeah, so LDA ABSX, LDX, ABSY, ABSX. Well, I could have probably, well, it's getting messy already, so it doesn't really matter where exactly I put this. Okay, so this is going to be STA absolute addressing plus X offset ABSX. So currently, if I leave this just as is, it should just simply rewrite the value. And it doesn't rewrite. Oh, that's because I didn't enable the execute yet in a test. So test. Yeah, let's enable the execute. So currently, it should just rewrite the value. Okay, it just has rewritten the 45 with 57, but it's wrong. We need to add the offset stored in the X register to the memory address, so eventually it gets written here. So STA STA ABSX. All right. Yeah, so here, let me just have a look at the 0 page with the X offset. Just to have the same order. Yeah, this one. So before, yeah, I can grab this. Yeah, should be enough. Just want to keep the code the same. So here I reset BX. I load the value of register X to BL, and I'm adding the value to AX, which holds the current memory address to write data to. I add the value stored in BX, in BL, but just because of the 16-bit, I'm using the entire register. And there should be the value of X, so it should be not 0104, but 0105. And there should be written the value stored at the register rate. So if I did everything properly, it now should print the value of what we have in the A register next to in 0105, literally. Yeah, and it does this. Great. Fantastic. All right. So yeah, this is pretty much all about it. So we just type it here. Okay, bring it here. So the flags should be the same. 7, 8, 9A, 3, 3. We have 3 bytes being added to the program counter, right? Because we've processed 3 bytes. This is correct. And now we have 0104 plus 1 in X, so it would be 0105, and here is the value, and here is the absolute address with X a register offset, or where we put the value of whatever we have in the A register, which is 57 hexadecimal, and we got it here. Yeah, so this should be just the case. Yeah, so far so good. So now let's quickly clone this for absolute with y. So this should be fairly similar. So LDA ABSY, and then here goes indirect ones. So I probably can bring it here. Yeah, again, it's getting a little bit messy already, and probably would be just better to put them in a little bit different order. But on the other hand, I don't believe this really matters that much. So yeah, anyway, here we want to store the value of Y register. Okay, and same thing. So same thing, but the offset would be stored in the Y register. Everything else should be fairly the same. Okay, so let's go to test 4. And this time, okay, so before anything else, I need to provide the test cases as well. So yeah, don't forget about the test cases. Copy. Yeah, this is important. This is important. So we're looking for a value of, well, it just starts given the errors, but this is just fine. STA ABSX redefined. Oh yeah. Register Y, yeah, my bad, plus Y offset. Okay, hold on a sec. Why the register didn't fail? Oh, that's because, okay, I need to reference in 0105. Yeah, now it fails, and this should be the value of 57. All right, so this should be the value of 57. Yeah, now PC fails, so it should be a, oh yeah, 0A, that's already what it should be. 0A. The flags didn't change. Yeah, okay, all done. Absolute X addressing. So far, so good. Yeah, this should be the case. This should be the case. Okay, guys, yeah, now the next one should be trivial because the tests are almost the same. So I dare to grab all at once. I dare to grab all at once. And let's see how the opcode is different. So this is gonna be 99. 99. Okay. Yeah, so let's not execute anything yet. And let's comment out this part for now. And I want to have 99. This is STA plus Y offset. Absolute addressing. Here it should be Y. Let's put some different value. We also need to load a value to the register Y. Byte register Y. Let's say offset of 3, for instance. Let's make it 2. Yeah, let's make it 2. So this is gonna be plus 2. Okay, and now we have a look. So indirect addressing, instruction, STA instruction, absolute addressing with Y offset, absolute addressing Y offset. Updated code, so 0106 currently 0100123456. So here we should have the value of 21, and we're going to be using this. Oh no, hold on a sec, guys. What do I don't know? This should still be like so. We'll use the offset, obviously. We'll use the offset. Yeah, we will use the offset. So let's call the execute, and let's print what we have there. Okay. So compare AL with whatever, with opcode 99, which stands for instruction STA with absolute addressing mode plus Y register offset. So STA absolute plus Y offset opcode. All right. And jump equals to STA ABASY, and I have that implemented already. So if so, then execute it, and this should actually be working. If only. Okay, so now I'm running out of bytes. It's not a big deal. That's because these tests really take enormously a lot. Well, let's actually have 10 segments, so not being bothered by this ever in future, hopefully. And here I just load 10 segments. This should solve the issue. Okay, and we have this 21 being stored exactly at 0104 plus 2 in the Y register, so 01001234 plus 2, 5, 6, right? And here we have the 21, which is correct. Yeah, so far so good. And now, guys, a real challenge would start. Yeah, because this was Code Monkey work so far. And now we'll start thinking, and you better not watching that. You better not be watching that, but yeah. Okay, so indexed indirect. Well, the very first thing I want to have a look at is if I actually can reuse the code for my indirect addressing from here. So what am I currently doing here? Why does it state that get the 0 page address? Actually, this gets the 0 page address. Yeah, this is correct. Yeah, because it's about to be stored in the 0 pages, right? So getting the byte from the 0 page address. Yeah, so after this instruction, we should have in AX, we should have the value of the absolute address to fetch, not to fetch, but to write the data to, right? Well, okay, so I would probably start from building the test case, and I would probably start with index. Yeah, hold on a sec, just test. Yeah, before that, okay guys, yeah, probably, you know, like, yeah, I probably won't be covering this in the video because you would just be watching me like this, thinking about what am I going to be doing next, and this can last forever really, so it's not really exciting to watch, I believe. So I would rather just finish the current test case, test 005. Yeah, I would rather just finish this test, and we end up here. And then we'll safely go for STX and STY. So now add the address. This one here should be 21, but now it gives up error, memory failed, and if I place 21, okay, now PC failed, so 0D, 0A, B, C, D, 3 bytes, correct, 0D, 0D, which is correct, yeah. Yeah, now it seems to be okay. Yeah, okay guys, I'm sorry, yeah, I just don't really want you to like staring at how I like thinking about the implementation. Yeah, I just need to stop talking in order to concentrate, to focus, and to make it done properly, because indirect addressing is the major source for creating bugs. So to avoid that sort of a thing, I would rather better focus on the work rather than talking. And once I'm done, I would just cover this test results and explain how exactly they work, and that would be a much better way of doing things, I believe. So yeah, this is it from my side. So yeah, thanks for watching. Until the next time, and take care.